All right. So October, November 2024, question paper 1-3. We'll try to skip past the easier questions and we'll like to spend more time on the difficult ones or the advanced questions. For example, here we have the first one. State which statement about physical quantity is correct? And for this one, a physical quantity, as we know, must always be having a magnitude and a unit. For example, length is a physical quantity. Length could be written as 10.0 centimeter. So it must be having a magnitude, it must be having a unit. So for the first one, D is the right answer. What is a reasonable estimate of the mass of a solid sphere of copper that has a diameter of 60 centimeter square? Now, one of the method is you can use a formula that mass equals to density times volume. You should be having an estimated value of density of solids, especially of metals. For example, the density of water is 1000 kilogram per cubic meters. The density of the solids and especially the metals is 5000 plus kilogram per cubic meters. So you can use that value of density, approximately 5000, and the volume of the sphere you can calculate. Since the solid is a sphere, you can calculate the volume by using the formula 4 over 3 pi r cube. So the radius would be 30 centimeter and 30 centimeter into meter would be 0.3. And the closest option that you'll be getting would be C. But a more practical approach is where you can make the estimation very easily. 60 centimeter diameter is pretty much the size of the yoga ball that we used in for workout, and if it is made up of, it's a solid sphere made up of copper, it won't be 0.1 kilogram, it won't be 10 kilograms, it would be kind of 1000 kilograms. But 100,000, that's way too much. It's even more than the weight or more than the mass of the vehicles, many times more. Anyway, let's move on to the next one. Question number 3. We need to find the units of this quantity. Okay, sigma. So you're not supposed to know this quantity. All you gotta do is to find the units of it. So I'm going to rearrange this thing, and now the quantity would look something like this. I'm going to insert the base units of all the quantities in the formula. For example, power is kgm to s minus 3. It is recommended that students should memorize the SI base units of power, especially now in paper 1, because you don't have enough time for paper 1. You should not be calculating the base units of power. Memorize the base units of power. Memorize the base units of force. Memorize the base units of energy. Memorize the base units of pressure. Memorize the base units of density. Likewise, area would be meter square and temperature would be Kelvin raised to the power 4. Meter square cancelled out by meter square. What are we left with? We are left with option B. So the third one, B is the right answer. Now let's move on to the next one. How long does it take for the stone to reach to the ground? Okay, so this is the second case of projectile motion where the object is launched horizontally. So initial vertical velocity is 0. I'm going to solve it with the vertical motion because I know the vertical displacement, 8 meters. So the expression would be S equals to ut plus 1 over 2 at square. According to the sign convention, which I explained in the topic of kinematics, the equations of free fall, if you're going below the reference point, below the starting point, displacement would be negative. So negative 8 equals to initial vertical component of the velocity is 0. So ut is 0. 1 over 2 as it is, g is minus 9.81, t square would be there as it is, negative negative would be cancelled out on both sides, 2 would be multiplied over there, it would be 16, 9.81 would be divided, and then you have to take square root of it, and the mathematics has to be done quick enough. So the answer in 2SF would be 1.3. So you need to try to solve the easier question as fast as possible so you can spend more time on the advanced questions. Let's move on to the next one. Okay, we are provided with a lot of thing. Which statement is correct? The upthrust. They are asking a question about the upthrust. Let me write down the formula of upthrust. Upthrust equals to density of fluid, could be water, could be gas, times the gravitational field strength times the volume of the object. All of these objects have the same volume. How do I know? Identical length, breadth, and height. All of these, for all of them, the value of gravitational field strength is same, 9.81. The density of fluid is same because all of them are immersed in the water, so the upthrust has to be exactly the same for all the cuboids. Even if they have different density, but the upthrust of the object does not depend on the density, rather it depends on the volume. So for 5, A is the right answer. Let's move on to the next one. In which example it is not possible for an underlying object to be in equilibrium? Whenever whenever the acceleration is not 0. For this, it is the option C. A speedboat changes the direction. Changes the direction means velocity changes. And if the velocity changes, the object is accelerating. What is the other example of this? An object moving in a circular motion, in a circular path. Even if it's moving at the constant speed, but the direction changes, hence it's moving with its velocity is being changed. And it does have the acceleration, which for the circular motion, it is known as centripetal acceleration. We study that as the first chapter in A2 physics. Two identical balls are projected vertically upward from ground level with the same initial velocity. Okay, ball X is in the vacuum and ball Y is in the air. Okay, ball X is in the vacuum, so there would be no air resistance, and the ball X would be able to cover more height. It would be gaining more height. So the ball X reaches greater height, greater maximum height, and takes longer than the time Y, than the ball Y, because there is no air resistance. So it would take longer. It has to cover more distance. It can reach greater maximum height. The case with the air resistance is, as the object is thrown upward, the air resistance would slow down its speed faster and faster. Yeah, for this one, the graph shows the variation of the velocity with time for a stone that falls from a bridge into the lake and sinks to the bottom. So as it falls downward, the velocity would be increased, and hence you see the velocity is being increased. So this is a portion where the object is falling through the air, and this is exactly the moment when the ball hits the surface of the water. As it hits the surface of the water, the velocity decreases, and this is probably the stage where the object reaches terminal velocity. So it doesn't reach the terminal velocity in the air, it reaches terminal velocity in the water. The rate of change of velocity is constant in the air. No, it wasn't constant. Otherwise, we would have been having a straight line. So we don't have a straight line in the air. The distance traveled in the water is greater than the distance traveled in the air. No. Let's say this is the distance traveled in the water. This distance is obviously smaller than this distance, than this one. So we are left with the option B. The acceleration in the air was decreasing with time. How do we know? Gradient of this graph, gradient decreases. How do we know gradient decreases quickly? We know because the steepness of the line decreases. Initially, the line was more vertical, and with the passage of time, the line is getting more and more horizontal. Let's move on to the next one. Question number 9. What is the resultant force on the car at 10 seconds? So 10 seconds is probably over here, exactly in the middle. To find the resultant force in 10 seconds, all I need to find is the gradient at this point. Since I have a straight line, I can simply find the gradient of the straight line, and I'll be getting the resultant force. Because if we have momentum time graph, then the gradient gives us the resultant force, the average resultant force. So momentum time graph, gradient, M represents gradient. Gradient gives us the average resultant force. Now what is the gradient of this straight line? It would be rise over run, or you can use y2 minus y1 over x2 minus x1. What is rise? Rise is a vertical distance, which is 4 minus 1 would be 3, but into 10 to the power 4. We need to be careful with the exponent here. Divided by run. Run is the horizontal distance, which is 20. So if you have a straight line, you can find the gradient between any 2 points on the straight line. I'm finding the gradient using the initial and the final point. You can use the initial and the middle point. You can use the middle point and the final point. Answer should be same because you have a straight line. Then we simply need to do some mathematics here. So it would be okay. So what's the simplest way we can do that? I can write it as 30 into 10 to the power 3 divided by 20. Then 1.5 into 10 to the power 3, which is 1500. Or just write it as it is on the calculator. Okay, question number 10. Two objects x and y form an isolated system. X and y collide and then separate. The mass of x is greater than the mass of y. Which statement about the collision is correct? Okay, even if they have greater or smaller masses, one thing is for sure, that the momentum lost by an object equals to the momentum gained by the object, or the change in momentum of one object is equal to the change in momentum of the other object. Or if the change in momentum is same and the two objects collide for the same interval of time, and if these two things are same, then the average resultant force which one object exerts on the other should also be same. So for this one, no, not only gravitational forces and the change in momentum is great, no, it should be same. The force y is greater, no, it should be equal. Exerts the force x and y exerts on each other act for the same length of time. Yes, they act for the same interval of time. Because they are in contact at the same time. So whenever during the period when they are in contact, they are exerting the force on each other. Okay, so kind of an easy one. For what kind of collision do we have? We have inelastic collision, so the total kinetic energy would not be conserved, but the total momentum is always conserved. So for 11 we have B as the right answer. So you see, many of the questions we can solve very quickly and we can save time in these. A tennis ball is thrown vertically upward. The tennis ball reaches its highest point and then falls back down to the point where it was thrown. Okay, All right. At which point on the path of the tennis ball is the resultant force on the tennis ball greatest? It would be either greatest at the starting point or at the ending point. So, which one of those two options do we have? We have this one. Just at the start after the tennis ball is released. At that time, it has the maximum resultant force, because at that time it has the maximum acceleration, and after that the acceleration decreases and decreases. Which statement correctly describes a couple? So couple is the forces that act in the same direction. No, exactly opposite. Couple is a pair of forces that act on center of gravity of an object. No, if the forces act on the center of gravity, they would not be able to rotate the object. And the couple is the pair of forces which would produce moment of force. No, they do not produce the resultant force, they only produce resultant moment of force. Okay, then we have the next one. I'm going to read out the last sentence. What is the torque that must be applied to the beam in order to maintain it in equilibrium? Uh, okay. Okay, this one is interesting. So we're not supposed to find a force, we are supposed to find the moment directly, or the torque, which means right now the system is not in equilibrium. And in order to maintain it or to keep it in equilibrium, there has to be a certain force applied somewhere. So a certain value of force should be applied at a certain distance in order to maintain it in equilibrium. So if the clockwise moment is slightly less than the anti-clockwise moment, then the amount by which the clockwise moment is less, that amount of torque or moment has to be provided. So what we are going to do is we are going to find the resultant moment or the resultant torque. How do we do? I'm going to find the resultant torque clockwise and the resultant torque anti-clockwise. One of them would be greater, one of them would be smaller, and in order to maintain an equilibrium, we have to provide a torque on a certain side so that the two torques are exactly the same. So what is a clockwise? Let me label the forces here. Options are in Newton. Okay, so this one would be 3 into 9.81. This is the weight here. This one is 1.4 into 9.81. This one is 6 into 9.81. So which one of these are clockwise? This is a pivot. P is a pivot. Only one is clockwise, and ACW, this is also ACW. So let us write the expression. Clockwise on one side. Clockwise is 6 into 9.81. This is a force. What is the perpendicular distance of that force from the pivot? 0.15 equals. The other two are anti-clockwise. The first one is 3 into 3 into 9.81 times the perpendicular distance of that force from the pivot is this one. How much is this? Since it's a uniform beam, so the center is exactly in the middle. The total length would be 0.6. I can add the two values at the top. The total length would be 0.60 meters. So the center would be at 0.30 meters. And if the center is at 0.30 meters, uh, sorry, then the distance of this force, sorry, this force, the distance of this force from the pivot is given directly 0.35. 0.35 plus the other force is how much? 1.4 into 9.81 times the perpendicular distance of that force from the pivot is this much, which would be 0.4 minus 0.30. How do we know? This one is important. All of it is 0.4 till here, and till the center it is 0.3 because it's a uniform beam. Then this distance is to be found out. It should be green one minus the blue one. So green one minus the blue one would be 0.40 minus 0.30 would be 0.1. So one of the side would be greater, one of the side would be smaller. And if you subtract the greater smaller value from the greater value, you will be getting 2.8 as an answer. The resultant moment would be 2.8. So I don't know which one is greater, clockwise or anti-clockwise. You simply subtract the greater moment from the smaller moment. Okay, let's move on to the next one. Here we have question number 15. The diagram shows three rigid which objects are in equilibrium. There should be no resultant force, there should be no resultant moment of force. This force and this force cannot cancel out each other, and these two cannot cancel out each other, so it cannot be in equilibrium. The downward force is not equal to the upward force because the force vertically upward, if the two forces were 50-50 exactly vertically upward, only then these two would have been cancelled out. Now there would be only a certain component of that 50 Newton. So the vertically upward force would be less than 100. What about this one, first one? The total force on the left side is 30, the total force on the right side is 30. Okay, so far so good. But these two forces would rotate it clockwise. So the resultant moment would be clockwise due to these two. And these pair of forces, or this couple of force would rotate it anti-clockwise, but you would see that the clockwise moment is going to be greater than the anti-clockwise moment, hence none of them would be in equilibrium. So D is the right answer for this. Let me check if everything is okay so far. Any message here? Okay, so I believe it's all good. Okay, then we have question number 16. We need to find, this is a repeated question. They have asked this question many times. We need to find the ratio of density of P to the density of Q. I'm going to take the point as the reference up till where the two liquids are separate, up till this line. So I'm going to take this one as the reference point. Because underneath this one, the two liquids are mixed. So I cannot use this as the reference. I gotta use this one as the reference. Now the pressure of the liquid P would be rho GH. The pressure of the liquid P would be the density of P times the value of G times the value of H. So above this reference point, what is the height of the column P? It is 2x. Likewise, I'm going to write the expression of pressure for the liquid Q. It would also be rho GH, but for this case, what is the density? Density of Q. G is as it is. Above this point, what is the height? X. And at this point, this is a point where the two pressures are same, because you see this is a surface where the two liquids are now mixed at this point. So at this point the pressure is same, because now you consider this thing as the single density. You can say their density is same, you can say their gravitational field strength is same, and they have the same height. So we can say pressure of P at this point only, at this reference line, pressure of P equals to pressure of Q. What was pressure of P? Density of P, G 2x. What was pressure of Q? Density of Q, G x. So G cancelled out on both sides. Density of P divided by density of Q would be x over 2x. Then x and x would be cancelled out. You'll be left with 1 over 2. This is a repeated question. They asked it many times. Okay, a stone of mass this much is thrown vertically downward with a speed. Okay, it does not fall from the rest. It is not released from a certain height. It is thrown with a specific speed. We need to find the kinetic energy just before the ball hits the ground. Sorry, the stone hits the ground. I'm going to find the velocity by which the stone hits the ground. So v square equals to u square plus 2as. V square equals to u square would be how much would that be? 20 square plus 2. Acceleration would be minus 9.81, and it is thrown from a height of 12 meter above the ground. So probably, let's say this is the ground. It was thrown from 12 meter from the ground. Let's say this is 12 meter. So it goes below the reference point. This is the reference. It goes below the reference. So minus 12, which would eventually be cancelled out. It would be 400. Need the calculator for this. Okay, so it would be, I don't need to take square root because I then need to find the, what do you call that, kinetic energy, and we need to find v square anyway. So 20 square would be 400 plus 2 into 9.8, come on boy, 9.81 times 12, and this one would be 635. So 635 here meter per okay, this is a value not for the speed, v square. I'm going to find the kinetic energy. Kinetic energy equals to 1 over 2 mv square. So 1 over 2 is 0.5. What is the mass? 0.3. What is a v square? 635. That's why I did not find the square root, because I can use the same value as it is, times 0.3 times 0.5. So what do we get is 95.3, which into SF is only 95. Okay, then we have the next one. A student can run or walk up the stairs to a classroom. Which statement describes the power required and the gravitational potential energy gained while running up the stairs compared to walking up? Okay, so if you have, whether you run, whether you walk, but if you have to cover same height, you'll be gaining same gravitational potential energy. So gravitational potential energy would be same either way. Option A and option B out of the window. We're left with C and D. If you're running, then you have to cover the distance in lesser amount of time. So you need to move faster and you'll be using more power. So for 18, it should be D as the right answer. Sorry, not the same power, more power, which is C. My bad. If you're running, in that case, the gravitational potential energy is same because you're covering the same vertical displacement. but it'll use more power. Okay, question number 19 will solve till question number 20, first half of the paper. Question number 19 is, what is the work done on the way during the process? So as a result, the weight moves through a distance r from x to y. It starts, okay, so weight is moving from here all the way to here. So the direction of the force of weight is this one. We need to find the distance parallel to the direction of force. So the product of force and parallel distance is the work done. The product of force and perpendicular distance is moment of force. So force is W and the distance parallel to force is Q. So WQ. Okay, let's move on to the next one. Question number 20, last one for today. Which one of these equations can be used for the derivation of kinetic energy? All the first three except for the last one, or should I say all of these except for the last one. So we use this one, we use this one, and we also use this one. We use v square equals to u square plus 2as. How do we use this one? V square as it is. Let's say objects is released from a certain point, so the initial velocity is 0. 2, acceleration can be written as resultant force over mass. Then this one can be written as S. M can be shifted on the other side. 2 can be divided here. Force into distance, which is the work done, and work done in this case equals to kinetic energy. Hence kinetic energy equals to 1/2, half of it, mv square, half of mv square. So we can use equation number 3, and you see equation number 1 is also used, and you see equation number 2 was also used in the process. All right, so here we have the next one. At which point on the graph does the metal wire stop obeying Hooke's law? And we are provided with a force extension graph. The material stops to obey Hooke's law as soon as the line starts to curve, which is the point A. So an easy one. A uniform wire is made up of a metal with the Young modulus this much. The original length of the wire is 2.4. The supreme constant K is this much. What is the volume of the wire? So the question can be done in different ways. The standard one is that you write down the formula of the volume, Young modulus. Young modulus equals to FL naught over AX. In this formula, E is the Young modulus, F is the force, L naught is the original length, A is the cross section area, and X is the extension. But if we combine these two, force per unit extension, collectively F over X is known as supreme constant. So instead of F over X, I'm going to write K, the supreme constant. Alright, so I can first find the value of area from here, cross section area from here, and then I can use this formula to find the volume. Cross section area times length of the metal wire would be the volume of the metal wire. So how do I find the value of A? Well, A equals to K L naught over E. K is a supreme constant, 2.7 into 10 to the power 4 times the original length is 2.4 divided by the Young modulus 1.3 into 10 to the power 11 So this gives you the value of A. I need the calculator for this. Can someone take out the calculator and solve it quickly? I'll solve this one, but meanwhile, someone can take out the calculator. So fraction 2.7 into 10 raised power 4 times 2.4 divided by 1.3 into 10 raised power 11. 4.98 into 10 raised power minus 7. And the volume would be this value of A, whatever the answer was on the calculator, times the length, which is 2.4. So answer times 2.4, I get 1.196 into 10 to the power minus 6. So D, 1.19 into SF can be written as 1.2. So for 22, we have D as the right answer. Then we move on to the next one, a rubber cord. Okay, what does the shaded area between the curves represent? So probably the easiest one. You see the stretching curve is this one, and the contraction curve is following a different pathway, and the shaded area represents the energy which is wasted in the form of heat energy, thermal energy. So what does that mean? It means, let's say if you were giving 10 joules of energy while stretching the rubber band, so the stretched rubber band was using 10 joules of energy, and when it's being contracted, you're not getting the exact 10 joules back from it. You're probably getting 8 joules when it contracts. The question is, what about the remaining energy? That energy is lost in the form of heat energy. And in this graph, that is represented by the shaded area. Then we have 24. In which situation would the stationary observer detect a sound with the lowest frequency? So for the lowest frequency, the observer has to be moving away from the source, or the source has to be moving away from the observer. Since observer is stationary, so the source has to be moving away. A and B eliminated, but we need to have the lowest frequency, so D. In both C and D, source is moving away, but in the option D, source is moving away from the observer faster. Question number 25. Which wavelength is correctly linked to the radiation? Which one is this? Okay. So you need to just memorize the table. For example, in this one, if I could tell you, ultraviolet falls, the wavelength of the ultraviolet waves falls in this range. This is a very important question for paper 1. If you had not memorized this table in paper 2, that's fair enough, but for paper 1 you must memorize it, otherwise you're losing 1 mark, 1 easy mark. So it must be memorized. Question number 26. Here we have question number 26. A transfer water wave has frequency 15 hertz and a wavelength 0.12 meters and the amplitude 4 millimeters. Okay, what is a vertical distance traveled by P in a time of 0.5 second? Mark this one as important. This is a very repeated concept. How much distance would be covered? Vertical distance would be covered by a point on the wave. Very repeated concept, very important concept. So I'll need to probably draw a line in the middle. This is, let's say this is a mean position, and the maximum displacement of a point from the mean position, aka the amplitude. How much is that? 4 millimeters. So 4 millimeters is the amplitude. Okay, and what I know for a fact is, if initially it is at point P, in one full wave cycle, how much vertical distance would be covered by this point in one wave cycle? If the amplitude is 4, how much vertical distance would be covered by this point on the wave in one cycle? Can anyone answer this question? 16 millimeter. Very good. Excellent. 16 millimeters. How do we know? Because in one wave cycle, it would first go over here, then it goes to the bottom, then it goes to the mean position back, and then it returns to the starting point. So it covers 4 times of 4 millimeter, which is 16 millimeter. So in one wave cycle, it covers 15 millimeters. So I want to find out how many wave cycles would be covered in this process in 0.5 seconds. How many wave cycles would be covered in 0.5 seconds? I want to find this one. So the time period of the wave is 1/15, because frequency is 15, so the time period is 1/15. So 1/15 is 0.0666, something like that. Okay, 0.67. You can also write 0.067. So this is the time period of the wave. In order to find the number of wave cycles, you can use the ratio method. So number of cycles means the given total time divided by the time period. Okay, it is just the same thing as ratio method. So total time is 0.5 and time of one cycle is 0.0666 something. Okay, can someone do it on the calculator? 0.5 divided by this value. $7.49. Okay, I can use it as 7.5. So what we know is, during a time of 0.5 seconds, 7.5 wave cycles would have been completed. And that makes sense because the time of one wave cycle was really small. It was 0.066. So time of one wave cycle was really small, and hence in a time of 0.5 second, 7.5 wave cycles have been completed. Now, for one wave cycle, the vertical distance was 16. For 2 wave cycles, it would be 2 times 16. For 3 wave cycles, it would be 3 times 16. And for 7.5 wave cycles, it would be 7.5 times 16, for which we get C. Yes, 120. Thank you. So you need to mark this one as important. This is a very repeated concept in what do you call that? In waves. They can ask you similar question for stationary wave. You solve it exactly by the same method. Solve it exactly the same way, unless there are some dramatic difference. Okay, a difficult question followed by an easy one. We are provided with the displacement time graph, and we need to show what is the distance along the horizontal axis between x and y represent, considering the fact we have time on x-axis, not distance. So if we have time on one axis, on x-axis, the separation between x and y is giving you the time of one wave, which is known as time period of the wave, aka period of the wave. So for 27 we have C. Keep it in your mind, guys, that you're going to get at least 9, 10, or in some cases 11 questions from the chapter of waves. Waves is the most important one for paper 1. Electricity is the second most important one for this paper 1. And then for mechanics you have mixed concepts, couple of questions from kinematics, 1 or 2 questions from dynamics, one question probably from moment of force, one from momentum, couple of questions from energy, work and power. So it's all mixed. But waves, the complete section, you must be expecting at least 10 MCQs from this section only. Okay, a stationary wave is set up in a stretch string which distance is equal to the wavelength of the wave. So probably the easiest one of the paper. Node to node is lambda by 2. Where did we study that? We studied that in chapter of stationary waves. Antinode to antinode, lambda by 2. So the wavelength of the wave would be double the distance between nodes, adjacent nodes, or double the distance between, sorry, antinode to antinode I meant, or double the distance between antinode to antinode, the adjacent ones, and the distance between node and the next antinode, the adjacent antinode, is lambda by 4. So you need 4 times of this distance in order to have one wavelength, but you need only 2 times of this distance or this distance to have one wavelength. Anyway, let's move on to the next one. Okay, my goodness, this looks kind of a lengthy one. So this one is from the topic, let us analyze. This is from the topic of double slit. Yeah, double slit, because we have 2 slits P and Q which are placed 80 millimeters apart. So this is basically the value of A, small a. Okay, I'm going to label the data first without doing anything. Let me label the data. Question looks slightly tricky, lengthy should I say, but I don't know if it's really tricky. And the separation between the slits, the distance between the slit and the screen, is represented by the symbol capital D. We don't have the wavelength, but you can help me find the wavelength, because in the formula of double slit we have this formula, lambda equals to AX over D. So we are provided with a frequency, and using the frequency I can find the wavelength. wavelength equals to speed divided by frequency, and since we have a light wave which is an electromagnetic wave, so the speed has to be 3 into 10 to the power 8. Someone please do it on the calculator. 1.5 into 10 to the power 12, and that's the wavelength. Okay, and after this I'm going to insert the value of wavelength. So please give me the value of wavelength. I can insert in the formula. 120 124. Okay, that was the old one. 2 into 10 to the power minus 4. So lambda, we do have the value of lambda also. 2 into 10 to the power minus 4. And let me read the final thing. Which distance does the sensor move through? Okay, the sensor travels through two intensity maxima, two intensity minima, two intensity maxima, and stops in the middle of third intensity minima. Let me find the value of x. Okay, I'm going to find the value of x. So 80 would be written as 80 times 10 raised power minus 3. X would be written as it is, divided by d would be how much? D would be 4. So x equals to 2 into 10 to the power minus 4 times 4 divided by 80 into 10 to the power minus 3. Okay, find me the value of x first, and then I'll move on from there. The options are in millimeter or meters. Okay, was in millimeter, but I'll convert it into millimeters afterwards. So 0.01, it would be in meters. We're getting this one in the standard units, 0.01 meters, and in millimeters it would be 10 millimeters. Okay, now once you have the value of x, even if you ignore all of it, you have found the value of x, but you should know what does x represent in this formula. So in this formula, x is the distance between two consecutive maxima, or the distance between two consecutive minima. And how much is that? Sorry, max to max, and the distance between two consecutive minima. It is 10 millimeters. So since you have covered 2.5 intensity minima, or you can also say you have covered 2.5 intensity maxima, because third one is not complete. You can see exactly here, and it stops in the middle of the third intensity minimum. So how many intensity minimums you have covered, the sensor has covered, or the sensor has traveled through? It has traveled through 2.5 intensity minima. So what is the distance for one of those? 10. What would be for 2.5? It would be 2.5 times 10, which is 25. So let's say this is minimum, first one. This is a central one. So first, okay, the center one, for the first intensity minimum, it was 10, and then the distance between the second minimum was 10 further, but it does not reach to the third one. Okay, uh, this one is the first value of minimum, this is the second one, and for the third one it doesn't cover the entire distance, rather it covers. And once again, the important thing is that if you get the interference pattern on the screen, the central line represents the zeroth order. You should keep it in your mind. The central line represents zeroth order. And then this is the first one. This is then the second one. And this is then the third one. But the central one represents zeroth order. So your first intensity maxima, this much distance is, or could be minimum also, because distance wise would be same, 10 millimeter here, 10 millimeter here, but for the third one it is only 5 millimeter, so overall distance would be 25. So yeah, it was kind of an advanced one, but we expect some easier questions, couple of easier questions underneath this one. Okay, which change will increase the amount of diffraction that is observed? Which change? I can see the wavelength is really small compared to the separation between the slits, or compared to the gap. So I need to increase the wavelength, but I know for a fact that they don't give me the option to increase the wavelength. Like 90% of the time, they won't give you the simplest option, which is increase the wavelength. Rather, they will give you the indirect option, which is decrease the frequency. So for the same speed, if you decrease the frequency, you necessarily increase the wavelength. So an easy one. Okay, probably an easy one here also. What is an electric current? It is the flow of charge carriers. So you see an advanced question but followed by two easy questions, so we can compensate for the time also. Okay, so this one is related to the drift speed. The diameter was d and the current was I, and then the drift speed was v. Everything very well. This one can be related by the formula v equals to I over NAE. But then the wire is replaced with a new wire of the same material, but with a different diameter, which is 0.5 times of the original. So if you decrease the diameter to half, the drift speed would not increase 2 times, rather it would increase, if you remember, it would increase 4 times. It would increase 4 times. If you reduce the diameter to 1/3, the drift speed would increase by 9 times. It would increase by square of 3. So it is related by a factor of square. Okay, but then they say the current, they change the current so that the drift speed is not 4v, it shouldn't be 4v, rather the drift speed has to be 3v. Let me ask you the question without doing any mathematics here. You see, we can very well do the question using the formula, but let's go with the concepts first. Initially, when everything was clear, current was I, diameter was d, drift speed was v, everything was easy back in the days. But then all of a sudden the diameter was 0.5. In that case, the drift speed is now being increased 4 times. But now they say, okay, we need the drift speed not 4v, rather we need to decrease the drift speed from 4v to 3v. How can we decrease the drift speed from 4v to 3v? Should we increase the current or decrease the current? Anyone who can answer this? If I'm to decrease the drift speed, should I increase the current or decrease the current? And the hint is here in the formula. Decrease, yes, because both are in the numerator. If you need to decrease the drift speed, you'll need to decrease the current. So what was my initial current? I. And if I'm to decrease the current, what should be my new current? 0.75. This is the only option in which we are decreasing the current. But then the question is, what if we have multiple options? For example, 0.75, 0.8, 0.9. How do we pick the exact one? Okay, we can try. So when the drift speed was V, current was I. When the drift speed is, when the drift speed was 4V, we'll compare with this one, with the changed diameter. When the drift speed was 4V, current was I. Now the drift speed is 3V, the current I2 is how much? We don't know. But then we can cross multiply because they are directly proportional. Any quantities which are directly proportional, you can cross multiply, or if you remember the formula, the ratio formula for drift speed and all that, this is a formula. Now what is V1? 4V. What is V2? 3V. What is I1? The initial current? I. What is the new current? We don't know. It's X. Then X equals to 3V over 4V times I. VV cancelled out. And what are you left with? The new current equals to 0.75 times the old current. This is a standard method, but if you want to save time, you should go with these tricks. Especially if you see that you have wasted plenty of time in the questions at the back, then you should be aware of these skills also. Okay, and then we have the next one, question number 33. Which graph could represent the variation of I with V? Okay, we need to read this. We have a fixed resistor and a diode combined by connecting them in series. Okay, so the situation for the diode is, the diode would not let the current pass through it unless it reaches a specific voltage, which is kind of 0.6 or 0.7 volts depending on the material. We can go with, let's say, 0.6 volts. So till 0.6 volts there would not be any current. So option C and option B eliminated, and then once it reaches a specific current, then the current increases proportionally. But you see, in the option D, we are having a sudden rise in the current even at a specific voltage, so it has to be A. So the current increases gradually. It does not have this portion. Okay, it should not have this portion. The current would increase gradually. It would increase from 0, then 0.1, 0.2. Question number 34. Okay, the potential difference across a fixed resistor was V and the power was 5 watts. Now the new potential difference has to be found out. And what is the new power? Power equals to energy over time. I can first find the power. 45 divided by 2.25. What do we get? 45 divided by 2.25. 20. Okay, so the new power is 20 watts. For the fixed resistor, because you don't know about the current, so you need to write the expression of power, and the other thing is the voltage. So power, voltage, and you need to write the expression for power and voltage without the mentioning of the current. So we have the formula P equals to V square over R. Okay, because we have a fixed resistor, so resistance is constant. So we know that if resistance is constant, I can write this expression like this. What if your question could be, what if we use the other formula of power? For example, P equals to I square R. The problem in this one is you don't have the direct information about the current, so this one is discarded. The second expression is P equals to VI. What about this one? Well, in this one, we don't have the information about the current, and we cannot say power is proportional to the current. We could have said this only if current was given as a constant value. If they say the current is constant, then we could have used this expression. But in this case, the current is not constant, so we'll write the expression in which the other variable can be kept as a constant. For example, in the first formula, the resistance is fixed, hence R is constant. Now power is proportional to V square. Power here, V square here. Initial power was 5, the voltage was how much? V. But we gotta write V square. Okay, you can also assume it was 1, and then you would write 1 square. Yeah, I'll better write 1. It'll be easy for you to understand. But we gotta write 1 square because the relation is with the square of V. Now what is the new power? The new power is 20. What is the voltage? We don't know. X square. Don't write X here once again. This is the thing that you can use with all the questions. If the relationship is with the square of a variable, then you need to write square in the ratio method. So x squared times 5 equals to 20. X squared equals to 20 divided by 5, which is 4. Then x equals to the unknown voltage is 2 volts. So I think you're not supposed to memorize the question, you need to learn the concepts. The concept here was, or the skill here was, one of them was that if you have multiple formula for a certain quantity, which one is compatible for to draw a relationship? The compatible one would be the formula or the expression in which the other quantities can be thought of as constant values. If you use the expression of power equals to, let's say, VI, okay, but what about the current? Current was not constant here. We don't know about the current, hence we cannot simply say P is directly proportional to V. P is directly proportional to V according to this formula, but only if I is constant. If resistance is constant, then P is directly proportional to V square. Okay, then we have the next one. Oh, so now we do have a question from potentiometer. You guys don't like the potentiometer, I know very well. So for this one, let me read the final thing first. Which condition must be met in order to determine this PDF? So we have a known battery and unknown battery at the bottom, and then E2, let's call the unknown battery E2, and then we find we use a fact that if the voltage across or voltage between the terminal XY is equal to E2 at a condition when there is no current in the galvanometer. No current in galvanometer. So no current in galvanometer means no current in the lower circuit. So no current should be flowing in this circuit, which means I2 must be 0. You can easily compare this circuit with any diagram of potentiometer. Is just the simplest circuit. There's no trick in this one. No trick, no play. So just a simple question. We use the fact that if there is no current in the galvanometer, then whatever the voltage between the point X and Y is, that would be equal to the EMF of the unknown battery. Okay, let's go to the next one. Which statement is not correct? Electromotive force is work done per energy transfer per unit charge. It is. Energy is transferred from chemical potential into in the cell to other forms of energy when the circuit is closed. Yes, in battery, it's from chemical to other forms of energy. The electromotive force of the cell is greater than the terminal potential difference when the switch is closed. This one says the electromotive okay, yeah, EMF of the cell is always greater than the potential difference when the switch is closed. Yes, it is. Yes, it is greater than, because some of the voltage would be dropped across the internal resistance of the battery. When the switch is open, voltmeter measures the electromotive force of the cell. Yes, it does. When the switch is open, no current flows through the circuit. I'm writing the explanation here. When the switch is when the switch is open, which means the circuit is off, no current flows through the circuit, and hence no voltage is dropped across internal resistance of the battery. And hence, if there is no drop across the internal resistance, your EMF would be equal to potential difference. Okay, which expression where E is in volts and R is in ohms gives the internal resistance R? Okay, easiest one. We have the formula, which I can then rearrange directly, equals to V plus IR. I need to write the expression for small r, the internal resistance, so it equals to this one. And you guys also know that in this formula V equals to capital I capital R. So E is E. What is capital V? I can find the terminal voltage using these quantities. Capital I would be 0.8 times 2.5 divided by the current. Which current is this? Yeah, this is an important one. In this formula, it is a current flowing through the battery, the current of the battery. So this is the value of current. So the two resistors are equal. Half of the current goes through the upper one, half of the current goes through the lower one. Hence, we can do the reverse engineering. We can say if the initial current should have been the sum of these two. So 0.8 would be 1.6. So 2.5 times 0.8 would be less than 2.5, which is, so I think C would be the option. You can multiply these two, 0.8 and 2.5. I'm sure it would be 2. There is no other option. Let's move on to question number 38. What is the rest mass of the beta particle? So the rest mass of the beta particle is not 0. It's not this one.